Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy in my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. Quick note about the foundation. We've started on our anxiety and depression codex. Our goal is to do a massive literature review of about 5,000 plus sources, which will be lectures, videos, interviews, peer-reviewed papers, etc., and to find every possible treatment for anxiety and depression and related disorders. So if you want to find out more information about the effort and possibly donate, go to findinggeniusfoundation.org. So today, my guest is Barbara Nadesan Horowitz. She's a cardiologist and evolutionary biologist on the faculty of Harvard Medical School. She's part of Harvard University's Department of Human Evolutionary Biology and also part of the Division of Cardiology at UCLA. And her research focuses on what can we learn from the natural world and apply it to human disease and human insights? She's the bestseller of a book called Zoobiquity, co-authored with Catherine Bowers. And we're going to talk to her today. So, Barbara, thanks for coming.
Happy to be here.
Well, tell me about, is your interest in helping people or is your interest in animals, or did the two come together? Like, what's a bit about your background and history?
Yeah, so I'm going to give that glib, well, after all, humans are animals answer, kind of perhaps in a bit of an annoying way to start. But the answer is, what I'm interested in doing is advancing our understanding of health and disease. And what I've learned after spending now almost 15 years away from what I was doing for the first 20 years of my career, which was practicing medicine, human medicine, as a cardiologist, as a professor of medicine. What I've learned in my voyage, over the last decade and a half is that trying to understand human health without also looking at animal health and, of course, the health of the planet that we share, that all species share, is futile. And we can make some advances in human medicine, and certainly we have, by being pretty anthropocentric, and the field of human medicine has been pretty anthropocentric. But by expanding the window through which we look at health and disease, and I'm talking about physical diseases like cancer and cardiovascular disease, but I'm also talking about mental illness. As we broaden that window and look at how these processes, in fact, emerge in these other species, we see so much more. And then, as we ask the question, well, why do we share vulnerability to cancer and heart disease and anxiety and depression and compulsions? Why do we share vulnerability to these issues with other species? Of course, we come to evolution, to common ancestry. And so the premise of all of my work is that we can understand some by adopting an anthropocentric approach, a human-centered approach. We can understand much, much more by seeing life and health and disease through a species spanning approach. Then as we really widen that aperture and add evolution into how we look at problems, we have a much deeper understanding of why we get sick. And by doing this, we can also, I think, accelerate innovation in terms of coming up with solutions for a lot of these problems.
Yeah, it's weird. I've noticed in science and evolutionary biology, the goal seems to be mostly to help humans, but then anthropomorphic thinking is also frowned upon. But yet we use mice for all these studies, which related and yet not related to us at all. It's just a very strange mix.
Yeah, there's a lot of contradictions, aren't there? I mean, it's funny. I remember being in maybe 5th or 6th grade and reading Animal Farm in class. And I remember the teacher introducing that word that you used, anthropomorphism. And what I remember was sort of her finger kind of wagging at us, saying, anthropomorphism is, projecting human characteristics onto an animal. It's not scientific. It's sentimental. And if you're a serious person, a serious scholar, a serious scientist, you ought to, recognize that impulse and suppress it. And, I certainly took that and agreed with it. And I spent, I did my undergraduate work in evolutionary biology. I went to graduate school. I went to medical school. I trained as a psychiatrist and I trained as an internal medicine and cardiologist. I absolutely never questioned the assumption that if you see a behavior in a non-human animal that resembles a behavior in a human, or if you see an expression, right, on a non-human animal's face that looks like an expression on a human face, I just assumed that, it was that we were so unique and different that to even consider the possibility that these were the same. In other words, that the mechanism, that the brain biology was the same, that was ridiculous. But then I had this experience that really changed my whole life. And it's in one sentence, it is that after years and years of practicing cardiovascular medicine at UCLA, I was asked to consult at the Los Angeles Zoo on some animal patients. And I began realizing how much shared vulnerability there was to all of these diseases, including mental illnesses. I started sort of reconsidering that reflexic assumption that it was an anthropomorphism. In other words, that if I saw a look on an animal's face or, a behavior, that to assume that it was, that my linking the two was an anthropomorphism. Well, I started to look at what's happened since the mid-70s when I was taking that English class. And a lot's happened scientifically, right? The entire field of comparative genomics is one thing, right? Which now allows us to literally know the extent to which we share genes that underlie all kinds of physical and mental processes. The entire field of neuroimaging and advanced neurobiology that has shown us tremendous commonality between not just humans and chimpanzees and apes and other mammals, dogs and mice, but tremendous commonality even with other vertebrate animals. And then finally, we have molecular phylogenetics, which, allows us to really pinpoint these commonalities and common ancestry. So we are living in a different universe than we were 30 years ago, 40 years ago, 50 years ago, scientifically. And today, I would say, if there is a scientific error to be made when looking at a dog with an expression on its face, given what we know about commonality, I would say the error would be the human exceptionalism that has been the basis of this fear of anthropomorphism, and that in fact today the default assumption ought to be, given what we know about the commonalities between human and non-human animals, default hypothesis should be that there is shared mechanism. Now,
people don't even our own cells, our own microbiome, they say is different from quote unquote us. Even
yes.
Our brain compared to the rest of our body still doesn't receive the same level of consideration. So how are they supposed to do that with animals? It's weird.
Well, that's right. That's right. Now, look, I trained as a physician and human medicine is one of many fields that have, historical traditions. Centuries of historical traditions that are very anthropocentric, very human centered. And, people kind of point back to Descartes and you can actually trace it, his duality, his, dual universe of man and animals. You can you can trace it back to Aquinas and to Aristotle. So, but this idea that humans are separate.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
That the human brain is separate, that the human soul is unique. These ideas are deeply entrenched in culture and in history, at least in Western culture and history. And so what that produces is just multitudes of unexamined assumptions about the uniqueness of the human experience. And that includes human disease. Now, I'm saying that as someone who, has practiced medicine for a long time, human medicine for a long time. And I have to say, I don't come from an animal-y background, let's say, right? My parents we didn't really have pets growing up. We went to national parks because we appreciated wildlife, but we were really not very animal focused. And my parents were psychoanalysts. And, Freud really believed that neurosis was a uniquely human privilege. And so I really was kind of grown up. I grew up steeped in a kind of human exceptionalistic point of view. Now that I have learned so much about what other species are capable of, what they're vulnerable to, and in terms of medicine, that while, yes, we humans do all kinds of things to dial up our risk of heart disease and cancer and obesity and anxiety, the fundamental vulnerability is ancient. The fundamental vulnerability that we have to these disorders, that vulnerability is ancient, and we share it with other animals living on the planet today. That is not something that I learned in medical school. That is not a sentimental statement. That statement is a result of an integration of what I understand about evolutionary biology and human and animal medicine.
Well, what do you mean? What kind of conditions occur in animals that people will be surprised to hear about? Right.
So I'll tell you the ones that surprised me when I first encountered them. So as a cardiologist, atherosclerosis is the most common diagnosis that I make. And it's atherosclerosis, of course, is the disease of the arteries that is responsible for the vast majority of heart attacks and strokes. And because, after World War II in the late 1940s, all of these GIs were streaming back into the United States, and these were young, strapping lads, and they had survived, battles. But one of the things that people were recognizing was that there was this increase, that there were lots and lots of young people, young men and women, who were dying of heart attacks. And of course, FDR, who had terrible high blood pressure, at Yalta, his physician was there with him. He recorded blood pressures of 236 over 130. That famous photograph where he's sitting with Stalin and he's sitting with Churchill, seriously hypertensive, really, really hypertensive. And he dies of a hemorrhagic stroke several months after Yalta. So sort of the world is all of a sudden looking at cardiovascular disease and thinking, oh my goodness, what the hell is going on? And you have to remember, and it's kind of hard to imagine this, but back then we didn't know that cigarette smoking could accelerate cardiovascular disease, right? Physicians smoked. My parents smoked. And we didn't know a lot about diet. We didn't really understand the connection between cholesterol and hypertension and all that stuff and heart disease.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
The Framingham Heart Study was initiated in the late 1940s, and that's the most famous prospective study. And they followed about 5,000 men and women in this little town in Massachusetts to see what they were, recording what they were eating, how much they were exercising, what their blood pressures were, et cetera, et cetera. And they began to see very quickly that the people who were smoking had higher rates of heart attacks and strokes. And the people who were hypertensive, that is, they had high blood pressure, had greater risks, et cetera. And from that, we came up with this idea that there are risk factors for atherosclerosis, right? And we all know what they are, right? We know cigarette smoking, bad for your heart, don't do it. And we tell patients, stop smoking if you want to reduce your risk of a heart attack, right? And we know that high blood pressure is risk. And we say, modify your diet, lose weight, exercise, do all these things because so there are all of these lifestyle changes that we recommend. And we say that this is prevention. All right. So listen, I was practicing medicine for a long time, teaching medical students. I certainly had a deep awareness of how modern human lifestyles contributed to heart disease. What I didn't know until I started really taking a deep dive into the world of veterinary medicine is that there are other animals who are very vulnerable to atherosclerosis, including birds. Now, not all birds. There are many different species of birds. And remember, we're talking about, I'm not saying that birds are dropping out of the sky with heart attacks, right? I'm not saying that but I'm saying that under the right conditions, these animals, their arteries are also vulnerable to atherosclerosis. And
what kind of conditions tend to cause this to happen?
Well, most of the cases that have been recorded are in captive animals, and that means that they're not getting the kind of probably physical activity and they're not eating the kinds of diets that they would in the wild. But some of the cases are in wild animals. And I do, most of the examples that I have of atherosclerosis, whether it's in a hippopotamus or whether it's in, an eagle or whether it is in a walrus. And those are all examples that I have, most of the cases are in captive animals, right? Where their lifestyles are sort of not wild. However, when these things do happen in captivity, but also in the wild, it shows that essential vulnerability is there. In other words, it doesn't mean that those animals are necessarily going to develop atherosclerosis, but that whatever the evolutionary history, that the trade-offs, right? Evolution is this process that is optimizing phenotypes. In other words, it's fitness, what we call evolutionary fitness, is sort of an expression of an animal's, survival and reproductive ability. Well, your ability to survive as an animal and to reproduce are about how aligned your body and your behavior is with the environment in which you find yourself. Do you have the necessary ability and skills to evade danger, predators and other dangers? Do you have the necessary physical ability and mental cognitive skills to leverage the opportunities in the environment for food and so that you can maximize your reproductive output, right? So evolution is this process, this hyper iterative process that is shaping, animals to be maximally optimized to their environments. And it's complicated, right? We aren't just a blood vessel that is, moving through time. Blood vessels, we've got this extraordinarily complex, body full of multiple systems that are interdependent. But the point is that sometimes a characteristic that makes us vulnerable, say to atherosclerosis, may also confer benefit to an animal. And sometimes those benefits come early in life and they're very important, even though an animal may pay the price with vulnerability to a disease later in life. But sometimes, Richard, that vulnerability is a consequence of the fact that characteristic may have been very adaptive, very fitness enhancing in animal ancestors. But in our species, which is 200,000 years old, right? It's a blink. In our species is no longer adaptive. So when I hear about atherosclerosis can occur in lots of different bird species. In some cases, they do develop heart attacks. In some cases, they do develop strokes. Breast cancer is another one. So certainly, we know a lot about breast cancer now and that rates of breast cancer are increasing in certain populations, women who, dietary factors, weight, age at puberty, exposures to environmental contaminants, all of those things are driving breast cancer rates. But it turns out other species in the wild also are vulnerable, that breast tissue of the human mammal, and, I've done a study where I've identified breast cancer in almost every single mammalian lineage, that this vulnerability is ancient. There were, over the course of about 15 years, there were a really disproportionate, unexpectedly high number of beluga whales who were washed, up on shore. Their carcasses were retrieved, and necropsies were performed. And at least half of the females had ovarian or breast cancer. A lot of them had breast cancer. And, this is sort of, for me, when I first encountered this was a little bit disruptive, because I'm not even sure why. There's just something disruptive about, a sort of a mini epidemic of breast cancer among these beluga whales in the St. Lawrence estuary in Canada. But in fact, what that says is that the vulnerability to breast cancer is probably as old as our human common ancestor with whales. And as it turns out also, that particular body of water was highly contaminated with polyaromatic hydrocarbons and other known carcinogens. And by the way, there was a higher than expected rate of breast cancer in women who were living around that area. So from atherosclerosis to breast cancer, those were unexpected, and really challenged me to think beyond that sort of narrow Homo sapiens centric point of view that I had. But then to be honest, and this is very, very interesting to me, I have two major research areas right now. One is part of the initiative that I launched recently called Female Health Across the Tree of Life. So the breast cancer vulnerability is part of that. But the other side is mental illness. And, as a child of two shrinks, and as someone who trained as a psychiatrist herself, I really had never thought about other species being vulnerable to psychopathology. Now, these days, many of us have dogs and cats who have anxiety or compulsions, and a lot of people know this because they're treating their animals with Prozac and related drugs. But what I learned about, and in Zubiquity, which was Catherine Bowers and my first book, we wrote about half the book is about mental illness in animals and humans, is that mental health and mental illness, that sort of balance that we struggle with as a human species, that we share that challenge with other species, whether it's eating disorders, whether it's self-injury, whether it's anxiety, whether it's compulsions, etc. Those things were a very big surprise to me.
Well, again, for some of these conditions, if the prevalence in people, let's say, is 20, 30%, but in animals it's 1% or less, what does that tell you versus if there's a pathology or disease that's, similar levels of incidence in animals and humans?
Right. So good question. That would be a wonderful, if we had that information, right? We certainly we know much, much, much more about the incidence of mental illness in humans than we do about its occurrence, outside of dogs, cats, horses. So animals who are, directly in our care and heavily bred. But you're right. If you know that the vulnerability is shared, but that the incidence or prevalence is much higher in one group than another, then that leads you to one of two conclusions. Either our essential vulnerability is higher, or we are, through our lifestyles, through our environments, through our exposures, through our social structures, that we unmask that vulnerability and we amplify it. In other words, that our human cultures is really contributing to increased rates of mental illness. And I happen to believe that is the case. But that does not mean that it's unique to our species. And it also doesn't mean that culture and experience is the singular cause. We have a neurobiology that makes us vulnerable. Asking why we have that neurobiology that makes us vulnerable is critically important to understanding it. And one very important first step to answering why is to ask what other animals living with us on Earth today, in other words, extant species, are also vulnerable to those mental processes. And can we begin to understand anxiety, depression, etc., through the lens of evolutionary biology?
So, in understanding that animals can have very similar pathologies to humans, what does that do for science and for health and for experimentation? Where does that push us? We haven't gone yet.
Yeah. So I'm going to start with a non-scientific takeaway. One big piece of this, and it connects to the science. So Tom Insel, or actually it was Steve Hyman, so one of the former heads of the National Institutes of Mental Health, has identified stigma, mental health stigma, as the leading barrier to, accelerated advances in mental health. Okay, stigma. Now, there's been a lot of attention placed on stigma, but the fact that it persists means we need to continue to think about ways to help, society and patients themselves recognize that this vulnerability is part of a natural legacy, let's say, that it's, that the shame and the kinds of theories of causation that are self-stigmatizing and blaming, that those are unproductive and not scientific. So I think knowing that the vulnerability to mental illness is not uniquely human, that alone maybe can help counter stigma, mental illness stigma. But from a scientific perspective, I think there are just a multitude of unexplored opportunities, starting with the kind of lowest hanging fruit, which is, I'll tell you a little story. When we were writing the first book, I had trained as a psychiatrist, as you know, and I had worked on an inpatient adolescent unit. And at that time, there were a number of patients who were self-injurers. At that time, they were called cutters. There were some other colloquial expressions, but it's not suicidal. It's not suicidal self-harm, but it's non-suicidal self-harm, cutting. All right. So when Catherine and I began exploring, just asking questions like, do other animals do X? Do other animals do Y? This seemed absurd to me. I mean, I was reluctant to even ask the question because it just seemed so clearly related to culture and human life in contemporary times. By the way, I'm sharing that, and I'm embarrassed at this point that that's what I thought, but it was what I thought. So what I quickly learned is that veterinarians know that there are certain kinds of animals that, if they're placed under certain kinds of conditions, will start to self-injure. And they will do things like bite themselves, pull out their hair, pluck out their feathers. There's a condition called feather plucking disorder. In some cases, they will lick and lick and lick and lick until their skin is raw and cracked and open. There are lots of forms of self-injury that occur in other animals. But there are types of conditions that will really pull it out and amplify it. And one of them is isolation. So an animal who's isolated is at higher risk of self-injuring. And the greater the isolation and the boredom, the greater the risk. And in fact, one of the reasons that in well-run zoos and aquaria, there are whole departments of animal enrichment in which they, despite the fact that the animal is in a captive environment, they're given, all kinds of opportunities to be challenged and to be physical and to not be bored. Well, it's interesting to look at self-injury, to take that veterinary framework and to apply it to the human-animal self-injurer. And it actually works rather well and has gotten me thinking about how we might use that kind of information. I mean, one just really fascinating parallel is that the degree of isolation in animals, correlates with the risk of self-injury and the severity of self-injury. The same thing is true among human prisoners.
Well, if you use basic thinking, who wants to be in a cage?
Right.
Who likes it? Who wants to be in isolation? So why is it a surprise? I would think it's only a surprise because
exactly. I'm having trouble hearing you, Richard.
People that.
That's right. The point was that prisoners who are in general population versus solitary confinement, you see rates of self-injury much, much, much higher in solitary confinement. And it's probably an attempt to self-stimulate, to self-soothe. And it's, shared across the tree of life. Yeah, absolutely.
Again, it seems like I don't know, I guess it shouldn't be surprising. You put a living thing in a cage or you keep it in captivity, no matter how wonderful the captivity.
Of course.
So in captivity, I mean, who would want to be kept in I guess it's like maybe going to the fabled federal prison where you can watch TV and, play tennis and all that, but you're still in prison,
Right. I mean, the reason that it's one of those sort of obvious, non-obvious kinds of things, but the idea that animals, that boredom and enrichment, right? That countering isolation with companionship, which is by the way why they put a goat in a horse's stall sometimes, or a chicken in a horse's stall, right? Countering isolation is feels like a not very fancy psychiatric intervention for cutting or non-suicidal self-injury. It's very clear and plain. And I think the idea that companionship, that stimulation, that purpose, those kinds of things that don't sound very medical can be used to treat or even prevent self-injury, those kinds of things. Those are the kinds of interventions that I think are pretty interesting. The other scientific opportunities around mental illness has to do with breeds. I mean, we know that certain dog breeds who have, different genetics than other dog breeds are much more vulnerable to certain mental illnesses. There are certain Doberman, for example, that suck their flanks. They do this compulsive flank sucking, and it's the mutation that underlies that behavior. It's known, and there are other tail chasing behaviors that have been linked to specific mutations in other dog breeds. And we can take those mutations, we can look at the genes that are those areas, and we can use those to improve our ability to identify regions of interest in human psychiatry. We can really accelerate the field of precision psychiatry.
So what areas of this, animal versus human pathology or study of pathology do you want to focus on from here? Which do you feel like are the most important? Is it mental disorders or?
I want to talk about the physical stuff, but I want to share some exciting, what I think is very exciting work, which in my mind is the future. And, so I've been talking to you about common ancestors, right? And what we can learn by recognizing our shared vulnerability to breast cancer, right? Let's say that, if I have a vulnerability to breast cancer and a platypus has another mammal like the echidna or platypus has vulnerability, that our common ancestor 175 million years ago, that she was also vulnerable. Okay. There's a lot we can learn by looking backwards in time, but we can also potentially find new solutions. And this is what I'm fully working on now in my lab by thinking about the differences in the physiology of other female animals, and I'm focusing on females, and how those differences represent solutions to problems that we haven't been able to solve. One big issue in medicine, in women's health, is the issue of high blood pressure during pregnancy. So there's a condition called preeclampsia, and it's very serious. It is one component of it is what's called gestational hypertension. So, high blood pressure during pregnancy. And it's a leading, if not the leading cause of mortality, fetal and maternal mortality. It's a very big problem. So what I did was I said, well, what are the non-human female animals, the species in which a high blood pressure might be tolerated? And I've been working on giraffe as my research kind of focus for a couple of years, because of course giraffe, their brains are 2.5 meters above their hearts. And so their hearts have to work very, very hard, which translates into a normal blood pressure of like 280 over 120 for an adult giraffe.
Oh, wow.
Right? For us, 120 over 80 is normal. So they have, and compared with all the other mammals, and we've done this work, they have the highest blood pressures of any other mammal. Okay. Now, if I had high blood pressure over a long period of time, I would develop kidney failure. I develop heart failure. I develop all kinds of eye problems. And if I was pregnant, gestational hypertension would put me and my fetus at really severe risk. But it appears that pregnant giraffes and their fetuses do just fine. How? And that's been the focus of my research, to really understand what are the adaptations, what are the evolved differences in the giraffe that allow her to tolerate this high blood pressure without the risk that, our species has. And, it's interesting and you can pinpoint it, and this is a lot of fun. I mean, this is kind of high school level biology, but, pushing the high tech button, because modern giraffe, the common ancestor, the most recent common ancestor of the modern giraffe is the modern okapi. And, if you don't know what an okapi is, you should Google it immediately, because they're really interesting and fascinating coloration. But modern giraffes and okapi shared an ancestor about 11.5 million years ago. Now, one of the big differences between an okapi and a giraffe is that a giraffe has a long neck, right? The cervical vertebrae are enlarged, which leads to this long neck, and okapi do not. And so what that means is okapi are the closest sort of relative to giraffe, but they have a not elevated blood pressure. And so what I've been doing is looking at the differences in the genes of relevance that are relevant to high blood pressure and pregnancy, etc., in the okapi versus the giraffe, to identify what this remarkable solution is that in the last 11.5 million years, since the giraffe and the okapi shared a common ancestor, what evolved adaptations happened. And once we've identified that, to see whether we can use that solution as a blueprint for innovation around this huge problem in women's health.
Well, what are the parallels? What do you mean?
Well, I mean, right now, this is the research. One of the things I've done similar research to figure out how is it that a giraffe doesn't develop heart failure from high blood pressure the way we do. And it turns out there is, probably suppression of fibrosis that stiffens the heart in us and in other mammals. So that's an adaptation. And that then is an opportunity to say, well, is there a way for us to leverage that information to develop similar kind of intervention to suppress fibrosis in humans? And similarly with the giraffe. I mean, in other words, what we're saying is that if you look around at the physiology of other mammals, other female mammals, since I'm focusing on female issues, all of a sudden you begin to see that there are solutions all around us for problems that we think may be intractable, problems that we haven't been able, that contemporary biomedical research hasn't found solutions for. There's like long lists of them. We women, when a woman is pregnant, of course, she shouldn't drink alcohol. Alcohol is, a teratogen. It can create an abnormal, embryo. And that's true in other species, but we know that there are many animals, millions of species that regularly consume fermented vegetation. So perhaps they have an evolved adaptation that protects them from the adverse exposure to alcohol. There are countless examples of how we can do this, and this is what I do in my research. I look at a big challenge in human medicine, whether it's a problem in women's health or whether it's a challenge in mental health. And I ask the question, has evolution already solved this problem? Can we identify another species that has unique physiology, unique biology that contains a solution that evolution, which is this massive research and development kind of endeavor, this hyper-iterative endeavor that we've not been able to solve, even with all of the high tech, even with all of the billions and billions of dollars that we've poured into it, that the answers may lie in the natural world, solved by evolution.
So are there any, again, where are you going to take your own work? Are there particular conditions that you want to go into more depth and look for the parallels, or is this more of an overall, you want to bring this to the scientific world so that they're aware of this?
Yeah, well, I mean, I'm working on this, the giraffe, the preeclampsia, and the heart failure, because I'm a cardiologist. It's what I know. But I'm also looking at infertility and reproductive senescence. There are female animals that are fertile, that conceive and produce healthy offspring for 150 years. We lose our reproductive capacity, by the fifth decade, 40s at the latest, right? So, there are those are the kinds of conditions I'm interested in. I work with different groups to, identify plausible hypotheses, to identify species that may be worth, looking at. And so I see my role as sort of really turning a light on for my colleagues in the human medical community, to not just investigators, but also clinicians, just to be aware of the natural world as this incredibly rich source of insights for human health. But, and it's a very, very big but we have to, in the 21st century, recognize that, the health of humans, the health of animals, and the health of the planet are interdependent, and that the best way at this point of taking care of human health, or one of the best ways, is to also be taking care of the health of other animals in the environment. And so in my work, I really do a lot of teaching, a lot of lecturing, a lot of talking to physicians, a lot of partnering, collaborating with groups who are looking at high impact human issues, right? So whether it's, cardiovascular disease, whether it's glaucoma, whether it's endometriosis, whether it's ovarian cancer, whether it's fetal alcohol, et cetera. Those are some of the projects I'm currently developing. But the idea is that we can no longer afford to be working in silos, that the exceptionalisms, whether we're talking about human exceptionalism or other exceptionalisms, that those are blindfolds. They're scientific blindfolds, and blindfolds prevent us from recognizing connections that once we are able to see those connections, allow us to, see much, much more and be more effective. So I see my role now as helping to kind of show specifically how different groups can use this species spanning and evolutionary approach, how to apply the lenses to ask better questions, hopefully do better research, and ideally come up with better solutions that protect not only human health, but also, again, the health of other species and the planet itself.
Very good. Barbara, what's, again, if you were to instruct, or if other scientists in other fields were to listen to you, which fields and which areas do you think need, the biggest push to incorporate this view?
Right.
The animals are similar to us.
Every field, there's not a single condition in which an expanded, broad comparative perspective can't help in an evolutionary perspective. I mean, if for no other reason, because we know that the environment increasingly is implicated in so many diseases, right? So there is not a single field that can't benefit. I love that question because it's sort of been a problem for me. Like, well, this can be applied to anything. Where do we want to start? So I guess best place to start is where there's been a kind of areas that have not received enough attention. And, we know now that, until 1993, women were excluded from many clinical trials, right? And until 2016, female lab animals were not regularly included in preclinical studies, right? So we've got some catching up to do when it comes to women's health. And we know that in the Anthropocene, climate and other environmental changes, they're impacting the health of everyone, but women and girls are disproportionately impacted by the adverse health effects of those things. So I think women's health is a really good place to start, and everything we learn from women's health is relevant to male health as well. Women's health includes pregnancy, which is the health of everyone, of the health of the next generation. And so I think women's health is a great place to start. And I do really feel that mental health there's a huge opportunity. There's a much bigger barrier because I think it's one thing to say, okay, fine, an echidna's heart and a human heart, they're both mammals, and okay, I believe that they're both vulnerable to the same things. But the human brain, now that's something that's extremely, extremely unique. And I think there's more resistance to the notion that, psychiatrists and others can really learn a lot by kind of diving into vulnerability to mental illness in other animals. But that barrier is absolutely, one can pull down that barrier, brick by brick with evidence, with discussion. And very often when I do this, what I discover when I have conversations with, other scientists and folks is that they kind of know this already. But again, we have so many unexamined assumptions that are the product of just centuries of layers and layers and layers of human exceptionalism, but that, now we can really begin looking at that. Not that there aren't ways in which we humans are unique. We are, like all species, we have unique characteristics, but we can begin to recognize that there's so much commonality, including in our vulnerability of our brains, of our central nervous systems to disease. And that insight can open the door to all kinds of, a new way of understanding why we get mentally ill. And what the nature of mental health is.
Well, very good, Barbara. Thanks for coming on the podcast. And where can people go for for their first look at your material? Should they buy Ubiquity, or where can they go to start engaging with your material and you?
Right. So our most recent book, Catherine Bowers and I, our most recent book is Wildhood, which is based on a Harvard course that we taught coming of age on planet Earth. And that's available, in all forms, as is Ubiquity. They can also go to my website. So that's, if you just Google my name, Barbara Natterson Horowitz, I have a website where a lot of the stuff that I'm doing and our conferences are featured. And I love to have conversations with scientists, particularly physicians, and lots of veterinarians and others in the human health professions and animal health professions. It's, this has been just an unexpected journey for me that, that started because I kind of stepped out of my human silo. So I'd love to hear from people if they have interest in collaborating or ideas. That's part of the plan.
Okay, very good. Well, Barbara, thank you for coming on the podcast, and I'm glad someone's thinking about this because it seems to be very rare, to the point of, I guess, I feel like it's put the brakes on actually what science can accomplish by having these views. So it's important to, to understand that we are animals, and again, that what they suffer from, we suffer from, and vice versa, not 100%, but a large part.
Right. Recognizing commonality instead of difference just seems like something we ought to be doing more of in the 21st century.
Well said. Well, Barbara, thank you for coming on the podcast. I appreciate it.
Oh, an absolute pleasure. Take care.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.